Welcome to this operations management tutorial introducing inventory. After this tutorial, there will be 2 additional tutorials on the various inventory models that we'll be discussing. My students can access the video tutorials for these problems using the content menu in D2L. YouTube viewers can access the video tutorials on my MOOC on udemy.com. I have a long and short version of the URL posted on the screen, and I will post this URL in the description. Inventory can be defined as a stock or store of goods. There are several different ways to break down inventory. One way is between independent and dependent demand. Independent demand items are the final products that are purchased by external customers. If you're Ford Motor Company, that's cars, trucks, and vans. Keep in mind that a lot of companies sell their products to other companies, so what they call independent demand might not look like final products to you and I. Dependent demand are items used internally to produce a final product. For Ford Motor Company, that would be engines, transmissions, and tires. Some of those they would make. They might make their own engines and transmissions, for example. Others they might buy. They would buy their own tires, for example. In other words, we use dependent demand items to produce our independent demand items. The screen shows a graphical illustration of what's called a bill of material. That is, the list of parts that are needed to make an item. We will talk a lot more about that in the MRP chapter, the Material Requirements Planning chapter. But for now, the item at the top, the widget, is our independent demand item. The things below it are all dependent demand items. So a widget is made up of 2 A's and a B. Those are dependent demand items, and we make them. How do we know we make them? Well, each A is made up of 3 C's and 2 D's. If we were buying the A's, we wouldn't need anything to make them. Each B is made up of 4 C's and an E. Notice that we use C's to make both A's and B's. That's fine. That could be nuts, bolts, or screw, something that's used commonly within the factory. We know that for the C, D, and E items, we buy them. How do we know that? Well, there's nothing below them, so we wouldn't have anything to make them out of, therefore we have to buy them. Independent demand is uncertain and based on a forecast. Dependent demand is certain and is calculated based on the independent demand. Well, what does that mean? Why is independent demand uncertain while dependent demand is certain? Well, Ford may not be sure how many cars they're going to sell, but they know if they're going to make 5,000 cars, they need 5,000 engines and 5,000 transmissions. Once you have a forecast of your independent demand, that has some error in it. We know that from the forecasting tutorials, but I can use that to calculate exactly how many engines and tires we need for Ford Motor Company. The purpose of a factory is to convert a steady stream of raw materials and other inputs into a steady stream of outputs. The purpose of a service is to convert a steady stream of raw materials and labor into a steady stream of outputs. The purpose of inventory is to meet the customer demand at minimum cost. If the customer comes in and wants to buy a Honda, wants to buy a hamburger, we've got to have things in inventory in order to meet that demand. We also want to carry that inventory at a minimum cost, as we'll talk about in the inventory models tutorials. As I said, there are multiple ways to break down inventory. We've already talked about one, independent and dependent demand. Another way to break it down is input, process, and output. Input inventory is anything we buy from another company, so it comes into the factory. We artificially call these either raw materials or purchased parts, but that's really somewhat misleading. If you're making air conditioners and you're buying compressors, they're not exactly raw materials, but they're not exactly a part either. They're a whole assembly, but that's the distinction that we make. Process inventory is inventory that we have started working on but haven't finished. This is sometimes called work in process inventory, although some textbooks will also lump in replacement parts, tools, and supplies. So that's the drill bits for the assembly line, the tools you need to change them, hydraulic fluid, things like that. And then there's output inventory. That's stuff that we've finished with, but we haven't sold yet. If we're still holding on to it, whether at the factory or at a warehouse, we call that finished goods inventory. If we're retail, we call it merchandise. And then it also could include goods in transit. Goods in transits are things that you have put on a truck at your factory and they're moving towards the customer. Now, whether or not they're inventory depends on when the title changes. If the title changes on your loading dock, then they're accounts receivable and they're the input inventory for the company you sold them to. If the title changes on their loading dock, on the customer's loading dock, then they're goods in transit. There's some other categories of inventory you might see. It's also possible that your textbook just lumps them in with the input, process, and output inventory. The first is tools and supplies. This is oftentimes just lumped in with work in process inventory and called process inventory. As I mentioned, that's the wrenches you need to change the drill bit, the hydraulic fluid, and things like that. You might see maintenance and repair inventory, sometimes called MRO inventory. This is extra parts to fix the assembly line or to fix the machinery. It's also maintenance items like fresh hydraulic fluid, filters for machines that use hydraulic fluid, things like that. And then some textbooks will list goods in transit separately from output inventory. And goods in transit inventory in this context are also sometimes called pipeline inventory, even though it's on a truck or a ship and it's not in a pipeline. Holding inventory is expensive. So given that it's expensive, why do we hold input inventory? One major reason is unreliable suppliers. Before I got into education, I worked for 20 years in the utility industry, specifically the electric utility industry. At the time, about 60% of our power was generated by coal. Occasionally, coal miners go on strike. If they do, you can't shut down 60% of your generation and say, sorry, state, we'll turn the electricity back on when the miners go back to work. So you have to have a lot of inventory so that you can keep running the power plants even if the miners go on strike. And there are lots of other reasons that a supplier might be unreliable. Maybe their suppliers are unreliable. Maybe the transportation is unreliable. Sometimes we hold inventory just because it's cheaper to buy more of it all at once. So that's economic order quantity. We're going to talk about that in one of the models tutorials. Sometimes we buy more than we need right now just due to transportation lot sizing. So coal is delivered to most power plants by train. A coal train has a certain length. When a utility company orders coal, they always order a train load, no matter how much they need. That's because it doesn't make sense to run half a train load out there because it costs the same for the engine and the labor and all. And realistically, most power plants use several train loads a day, so it wouldn't make sense anyway, but that's transportation lot sizing. When your local furniture stores buy mattresses, they always buy a truckload, whatever size truck the deliverer uses. That way, they spread the delivery cost over as many mattresses as possible. We can also buy inventory now if we think the price is going up as a hedge against those price increases. You have to be careful with that, though. Several companies that I know have bought large quantities of inventory to hedge against price increases, only to have the prices fall, and they were stuck with more expensive inventory. Why don't we hold process inventory? Well, not everybody does. If you produce on an assembly line, then the closest thing you have to process inventory are those items that have started on one end of the assembly line but haven't come out on the other end of the assembly line, and that's not really what we mean by process inventory. So when we talk about process inventory, we're typically talking about job shops. That's where we have a lot of different machines roughly connected to each other using forklifts and pallets and things like that, and different jobs take different paths through the system. Those machines run at different speeds. If we have a slow machine feeding a fast machine, the fast machine will keep running out. So we have the slow machine build up inventory while the fast machine works on something else. When there's a lot of inventory, then we have the fast machine start working on that built up inventory. This helps to match the capacity of the various machines. So why do we hold output inventory, finished goods inventory? Again, not everybody does. We might be using it to match production to demand. So we might want to produce at a steady rate while demand varies up and down. When demand is low, we build up inventory. When demand is high, we draw down inventory. Just like there's an economic order quantity, there's oftentimes an economic production quantity. So it might make sense to make more now than you need right now to minimize your setup costs. If our demand is uncertain, we might want extra output inventory as safety stock to make sure that we don't run out. The more variable our demand, the higher the level of safety stock we're going to carry. And sometimes it's just easier to schedule when we're scheduling in larger lot sizes. You put all that together and we have 8 functions of inventory. 1, to meet anticipated customer demand. For manufacturing, that's finished goods inventory. For service, that could be finished goods inventory or it could be raw materials inventory. 2, to smooth out production requirements. 3, to decouple operations, that's primarily work in process inventory. 4, to protect against stockouts. That could be raw materials inventory or finished goods inventory. 5, to take advantage of order cycles. That's going to be raw materials inventory. 6, to hedge against price increases. Raw materials inventory. 7, to permit operations. Raw materials inventory and, to a lesser degree, process inventory. 8, to take advantage of quantity discounts. Raw materials inventory. The objective of inventory control is to achieve satisfactory levels of customer service while keeping inventory costs within reasonable bounds. The more inventory we hold, the higher the inventory holding cost, but the higher our service level. The lower levels of inventory we hold, the lower inventory holding cost, but the lower our service level, so it's a balancing act. Our use of inventory is measured by a ratio called the inventory turnover ratio. It's the ratio of average cost of goods sold to average inventory investment. The higher the inventory turns, the better. And it's the number of times you turn the inventory over in a year. So if you have an inventory turn ratio of 3, that's equivalent to using up all of your inventory, restocking, using up all of your inventory, restocking, using up all of your inventory 3 times in a year. If your inventory turns is 5, you're doing it 5 times. So if you're doing it 5 times, you're generating more profit out of the same space, machinery, labor than if you're doing it 3 times. So the higher the inventory turns, the more profitable you are. However, this is very industry specific. Grocery stores, for example, tend to have very high inventory turns, in large part because their inventory is perishable. A steel mill has much lower levels of inventory turnover. You can't compare between the two. So when you're comparing inventory turns, you're always doing it within the same industry or with the same company over time. The inverse of inventory turns is called days of supply. That is roughly equivalent to how many days it takes you to empty all of your inventory. There's a formula to switch between inventory turns and days of supply. The higher the level of inventory turns, the better. The lower of days of supply, the better, because the lower the days of supply, the more quickly you're turning over inventory. It takes several things to effectively manage your inventory. 1, you need a system to keep track of inventory. That doesn't sound like a big deal, but a lot of factories have very large warehouses, and they don't always put inventory at the same place. If they're using a lot of it, they'll get a big bin for that inventory. If they're using just a little bit of it, they'll move it to a small bin somewhere else. Your inventory control system has to keep track of that. 2, you need a reliable forecast of demand for your inventory items. Some of that's going to come from the demand forecast being converted into its components that we need to make those items, the MRP process. Others, like the amount of hydraulic fluid you need or the number of drill bits you need, are going to have to be calculated separately. You need to keep track of your vendors, so you keep track of the lead times and you know if it changes. Lead time is important in knowing when to place orders. We'll talk about that in the inventory models tutorials. 4, you need to get reasonable estimates of the holding cost, the ordering cost, and the shortage cost to the best that you can. Those are used in calculations in the inventory models tutorials. And finally, 5, you need a classification system. We've talked about 2 already, but what we're talking about here is an ABC classification that we'll talk about in a moment. There are 2 broad types of inventory counting systems. The first is a periodic system. This is where a physical count of items is made at periodic intervals, once a week, once a month. The second is a perpetual inventory system. This is a system that keeps track of removals from inventory continuously, thus monitoring current levels of each item. In other words, you keep track of it on the computer. You bump up inventory when you get a shipment. You decrease inventory when you use some of it. The thing is, there are still mistakes. People forget to log in incoming inventory or forget to log their usage of inventory. So even with a perpetual inventory system, you have to occasionally count. You have to true up the system to make sure that what the computer thinks you have in inventory is what you actually have in inventory. As I said, with a periodic system, physical counts of items in inventory are made at periodic intervals. The more important the inventory, the more frequently you're going to count it. This is mainly used at small grocery stores and small retail facilities. So basically, businesses where counting would not be a major burden. It would also be used at businesses that couldn't afford the cost of the equipment needed for a perpetual inventory system. However, computers are cheap now, barcode scanners are cheap, and really it's very cheap and easy to keep track of this on the computer, so you rarely find a company that would benefit from a perpetual inventory system that doesn't have one. The big advantage of the system is the orders for many items occur at the same time. So you're not placing an order today, tomorrow, the next day for different items. You're going in once every 2 weeks and counting and placing a big order. It reduces your counting labor. How does it do that? Well, you only count at those regular intervals. The disadvantages are you have a lack of control between review periods. So if you're reviewing every 2 weeks and you run out at the end of 1 week, you don't have any system to deal with that. That means you need to carry extra safety stock to avoid stockouts. And each time you do the count, you must decide on how many you're going to order. A perpetual system is a system that keeps track of removals from inventory continuously using a computer and a barcode scanner most likely. This system allows us to know approximately, not exactly, but approximately how many of each item we have in inventory at any point in time. I say approximately because of human error. You'll find this at large retailers like Walmart and larger factories. Speaking of Walmart, Walmart never knows what they've got exactly. It's no fault of Walmart. There's unfortunately a lot of pilferage, and the shoplifters don't stop at the door and let you scan what they've stolen to decrease your inventory. So basically, any facility that's large enough where the technology makes sense has the technology and uses a perpetual inventory system. The advantages are the control provided by continuous monitoring, so you always know when you're about to run out. Since you're using a fixed order quantity, management can set up an economic order quantity to minimize the cost of the inventory. The disadvantages are the cost of equipment, although that's not a big deal anymore, and the fact that you still need to make a physical count every now and then in order to true up the system. Almost every grocery store uses a perpetual inventory system. But if you've ever been out there and seen the employees scanning the barcode with this gun-looking thing and then punching a number into the top, what they're doing is counting the items on the shelf and entering it into the computer. They're truing up the system. There's also an inventory control system called a two-bin system. That's where you have two containers of inventory and you reorder when the first is full. So for example, a small hardware store might have a big barrel of nails that they sell out of. When the barrel runs empty, they pull out a small bucket from underneath the counter and sell out of that and order some more nails. The small bucket is sized to be approximately what they're going to sell during lead time until the replacement barrel comes in. Many hospital rooms have two bins that are stocked exactly the same. They take items out of the first bin until anything in the bin runs out. They take the bin out, they send it down to the pharmacy to be refilled, they start on the second bin. The refill comes back, they put it in, continue using the second bin until something runs out. They send that to the pharmacy and go back to the first bin. In the hardware case, one bin is larger than the other. In the hospital, the two bins are exactly the same. But it's the same process. Just use one until you need to refill it, switch to the other one. It's actually cheap, easy, and you don't need to count anything. You just wait until something runs out, and then you replace everything in the bin. Let's talk about two things that are almost universal in inventory. The first is a barcode, sometimes called a universal barcode. You all know what that is. You've seen it thousands of times. It's a graphical design printed on a label that has information about the item to which it is attached. It's not just for consumer items. Items in factories have barcodes. The work center will scan the barcode as they use the item or as they work on the item or just to keep track of the item. In industrial settings, barcodes are being replaced by RFID tags. That's short for radio frequency identification. There are two types, passive and active RFID tags. You are most familiar with passive RFID tags. That's what you see on the screen, that small little thing on the person's hand. Passive RFID tags are tiny. They don't have a battery. And RFID tag reader sends out a signal, a radio signal that says, "Tell me about yourself." It takes in that radio wave, converts some of it to internal energy, then uses that energy to send out its serial number. And that's all it can send out is its serial number. The reader has to interpret that based on a database. Passive RFID tags can be bought for, in bulk, less than a penny a piece. They're extremely cheap. Active RFID tags have a built-in battery. They're much larger. Their size depends on how much battery you need in them. They're a good bit more expensive, but they can send out a much stronger signal. The military, for example, uses active RFID tags to keep track of explosive ordnance when they ship them. I know some factories that will put an active RFID tag on an item that's being made in the factory to track it all the way through the factory. That way they know what workstation every single unit's at. One of the factories I'm thinking about in particular makes air conditioning units, larger industrial air conditioning units, so they can always know where every single item is in production. Now let's talk about some key inventory terms. Lead time is the time interval between ordering and receiving the order. So you call up the vendor and you say, "I want 100 units. 3 days later, a truck shows up on your loading dock with 300 units. That's a 3-day lead time. Holding costs are the cost of carrying an item in inventory for a length of time, usually a year. Holding costs are also known as carrying costs. Purchase cost is the amount you pay to buy the inventory. That includes both the amount you pay the seller and the cost internally that you have to pay the people to place the order. When we make it ourselves, rather than ordering it from a vendor, we call it a setup cost instead of an ordering cost, but it's used in the formulas exactly the same way. Finally, there's shortage costs. These are costs that we incur when demand exceeds supply, so we run out. This is loss of goodwill, loss of sales. It's hard to get a firm grasp on shortage costs, and it's usually just estimated. We've talked about several different ways to classify inventory. Let's talk about another one. This is an ABC classification. A items make up the bulk of your inventory dollars. Not the number of items, but the bulk of the dollars. It's usually 10 to 20% of the count of the items, but 60 to 70% of the dollars that you have tied up in inventory. So if you're Ford Motor Company, these are cars, trucks, and vans. B items are less important than A items, but they have a value high enough to be managed well. They make up about 30% of the count of your items and about 15% of your dollars tied up in inventory. C items are low-cost inventory items. You have very little money tied up in them, typically 10 to 15%, but they make up the bulk of your inventory items, 50, 60%, even higher. These are nuts, bolts, and screws. A items are going to be tracked closely. If you're counting them to true them up, you're going to count them up once a week or once a month. You would want very accurate inventory records, say plus or minus 1/10 or 0.2%, and you may even keep the items under lock and key. At a jewelry store, the jewelry might be an A item. B items might be counted quarterly. You might look for a 1 to 2% accuracy level. You might manage them centrally, but you're rarely going to keep them under lock and key. For a jewelry store, that might be watches. C items are typically stocked right at the work center. You rarely count them. In fact, you probably never count them. Instead, you measure them. You might weigh them. I have 10 pounds of screws, or you just might look at the container and estimate I've got half a barrel of screws. And you're really not going to worry about having that close of an inventory record, maybe 5% plus or minus. For a jewelry store, that might be watch batteries. And yeah, I know that's not watch batteries on the screen, but I couldn't find a good photograph of watch batteries. If you go into a jewelry store and ask to look at the jewelry, the diamonds or the rings, they're going to let you look at one at a time, and they're going to stand there and watch you like a hawk. If you go in there and tell them you need a battery for your watch, they may just hand you a box of batteries and tell you to find the one you need and walk off and help a customer. Come back later and have you pay for it. They're not worried about you stealing it. Since we've talked about counting and truing up inventory, let's talk about cycle counting. Cycle counting is a physical count of the items in inventory on a regular, reoccurring cycle. Typically, you want higher levels of accuracy for A items, less for B, even less for C. Now, the issue is when should cycle counting be performed? A items are going to be counted most frequently. C items are going to be measured less frequently. B items will be somewhere in the middle. But this is also going to depend on the industry and the items. If you've got things that you're not the least bit worried about being pilfered in inventory, say railroad ties and railroad rails, you may not check it that often. If you're a Walmart with lots of things that might get pilfered, or you're a grocery store with things that might spoil, you might count a lot more frequently. And who's going to do the counting? If you're big enough, you will have people whose job it is to do the counting. If you're not big enough to have a counting department or a counting person, then one of your inventory clerks will take care of it usually. If you enjoyed this video, please click like and consider subscribing to this channel.